Hey there, fourth graders. Welcome back to what is basically Circuits Part 2. If you take a look at your screen, this should look familiar. This is what we talked about last time, circuits, worksheet page 11, and they walked us through what the basics of a circuit is. Remember, we learned that electrical current, which is the same thing as electricity, electrical current, it needs two P's to flow, a push and a path. A push is the source of electricity, like a battery, and the path is what the electricity flows on, like the wires. We also learned that a circuit can be open or closed. If a circuit is closed, everything is connected, everything is working, electricity is flowing. The light bulb is lighting up, the machine is working, whatever it might be. If a circuit is open, then that means something's not connected right, maybe something is broken, maybe the light bulb doesn't work. No electricity is flowing. Electricity needs a complete path, a complete circuit to flow. So if it's closed, everything's working and good to go. So today we're going to take our paper, flip it over to the back side. They're going to take us a little bit further, and the main idea of the backside here is the fact that there are two types of circuits. What are they, and what are the similarities and differences between them? So let's take a quick look here. Reading on the top. There are two different types of circuits, a series circuit and a parallel circuit. In a series circuit, the electrical devices in the circuit are lined up one after another in a series. In a parallel circuit, each device is on a separate branch of the circuit. Imagine a circuit with the following components: a battery, circuit wires, and two light bulbs. In a series circuit, both bulbs share the same circuit of electricity. That means they're on the same path. Because both bulbs are drawing power from the same circuit of electricity, each bulb receives less voltage, making both bulbs dimmer. Unfortunately, if one light bulb breaks or the circuit of electricity is broken, neither light bulb can work. Last paragraph. In a parallel circuit, each light bulb is connected to the battery by its own separate branch of electricity. If one light bulb is broken or burned out, the others can stay lit. However, a parallel circuit uses more electricity than a series circuit and causes the battery to run out of energy more quickly. All right, now that might be a lot of new information for some of us, so it might take us a little bit of time to wrap our minds around what is the difference between series and parallel and what do they look like. Well, let's take a look at the bottom and see if we can make more sense out of it. Question 5 says, identify each diagram as series or parallel. And I had to change some answers around. I don't know what I was thinking. So if you take a look at A, this is an example of a series circuit. Remember at the top it said, in a series circuit, the electrical devices, or in this case the batteries here, they're all lined up one after another in a series, kind of like everything lined up all in a row. This is a series circuit. Which means 5B, look at this one. This is an example of a parallel circuit. Up at the top it said, in a parallel circuit, each device, or light bulb here, is on a separate branch of the circuit. Check out the light bulbs here. Each light bulb has its own path to the battery. What if this light bulb burned out? Wouldn't this bulb and this bulb still have their own path to the battery? Yeah. So this bulb can be burned out, and these two can still be all lit up. Over here, if one of these bulbs burns out, notice there's only one path. There's only one way for the electricity to flow. If one thing gets broken, one light bulb gets broken, nothing works. So over here, one light bulb is out, they're all out. Over here, one light bulb breaks, the other two can stay lit. Big difference. Let's go down to number 6. Complete the table by identifying the pros and cons. Pros are positives and cons are negatives. Okay, so if we go here, a series circuit. What is a pro? What's something positive that we could say about that? Well, it's more simple to create. You would use fewer materials, which would mean it would be cheaper to design, cheaper to build. And it uses less electricity as well. A con or a negative. Well, if there's one problem, nothing works. Remember up here, one light bulb breaks, all of them are done, none of them light up. That's a negative. If there's one problem with the circuit, nothing works. And because they're all lined up in a row, they're all sharing the energy, the bulbs would be dimmer in that circuit. The light bulbs would not light up nearly as much. Okay, so now let's go down to a parallel circuit. What is a pro? What's a positive that we can say about parallel circuits? Well, the cool thing is that each bulb has its own path to the battery. If one bulb breaks, the others can stay lit. The electricity keeps flowing through them. A negative or a con, well, it is more complex to design and to build. You use some more materials, some more wires, so it'd be a little more expensive, and more energy is used, and the battery would run out of energy quicker. So there would be a negative about the parallel. Okay, part C, we're almost done here. It says, imagine you are putting up a string of festive lights at your house. It must be Christmas time. Spreading some Christmas cheer. When you plug the lights in, none of the lights turn on. That would be frustrating. Okay, 7A. What could be the problem? You plug in the string of Christmas lights and nothing lights up. What's the deal? What's the problem? What's going on here? Well, more than likely, you either have maybe a damaged wire to make the circuit incomplete, or you have a broken bulb. Those are two pretty common problems. Problems with the wires, problems with the bulb. One or the two. 7B. What kind of a circuit was most likely used in the lights? Well, remember, you plugged it in, and how many lit up? None. None of them lit up. That's because they're all lined up in a row. And if there's one problem, nothing works. So more than likely, what type of a circuit is this? Yeah, that's a series circuit. Okay, in number 8, describe a type of circuit that could avoid this problem. What if you don't want all of your Christmas lights to go out just because one bulb is broken? What do you need to do? Well, you need to get those lights on a parallel circuit. You want to make sure that your light or your Christmas lights aren't on a circuit like this all lined up. You want to make sure that each bulb has its own path to the electricity, its own path to the source. That way, if one bulb goes out, the rest stay lit. So that's what you really want for your Christmas tree and your Christmas lights on your house, things like that. A parallel circuit. All right, we made it down to the end. If you've got any questions on circuits, a push or a path, opened or closed, series or parallel, please let me know. Jot down some questions, maybe write them in a Google Doc and share it with me. I'll get back to you as soon as I can. Thanks, guys.